We're going to start by looking at a couple of little of these little visual demonstrations. So on Friday when we did similar triangles, so this starts relating to similar triangles. This is just a quick little understanding, like big picture, what is trigonometry? What is this stuff that we're about to do that's very different from stuff that you've seen before? So what did we learn about similar triangles? Two triangles are similar if they share the same three angles. Okay? So I could draw a triangle. Let me draw a triangle here. And let's say this is 30, and this is 90, and this is 60, and I could draw a bigger one. Whoops, that was bad. And this is 90, and this is 30, and this is 60. So because they share the same three angles, they're similar. What does similar tell us? It tells us the side lengths are proportional to each other. And that's something that you need to think about to understand exactly what that's saying, but it's not all that complicated. And so, hey, what's going on here? So what that means is, if you look at this example, the hypotenuse here is twice the length. It's not exactly, this is rounded, so it looks a little fishy when I start moving things around, but the hypotenuse 12 is twice the length of that far side over there. 12 is twice 6. Okay, and again, my angle is 30 degrees. This one's 90, so the top angle there would be 60. So what similar triangles tells us is I can make this bigger, but I haven't changed any of the angles. You see how this is still 30 and this is still 90? And what's the ratio between those two side lengths? The hypotenuse is twice that vertical side. And so that will be true because when I drag this dot, I don't change the angle. So that'll be true everywhere I drag it. 8 and 4, 10 and 5, it's rounding, so that's why it looks fishy when it's like, wait a minute, 9 and 5, what's going on there? Don't worry about that. 6 and 3, and again, back up 22 and 11, if I drag it around, it's always twice, basically. Does that make sense? Chris, are you with us here? Yeah. Okay. So that's really important. So what is trigonometry? Well, that means, think about this. If I have a hypotenuse that's 12 and a side length that's 6, this angle has to be something specific. Because every triangle that has that relationship has the same angle. That means I could draw any old triangle I wanted to. I could draw another triangle up on the board. Okay, and it's, let's say I'm going to make it different. Okay, I'll just make it like that. And if I say this side length is 10 and this side length is 11, this angle has to be something specific. Right? Because every triangle, like I could do another one that has 20 and 22, right? Same kind of proportion, and it'll have to have the same angle. They have to be equal. Here's another little demonstration that might help you visualize that. Think about this. Watch what happens when I drag this dot and I change the length of this line. Okay, so the 9 is going to change. If I make that line longer, this angle doesn't change, but this one does. It has to get bigger, right, for those side lengths to still connect. So as I change this side length, this angle has to change in length. So there's a connection, and this side length doesn't change length. So there's a connection between this angle, this side length and this angle. And similarly, if I do this, if I change the length of this side, that side length doesn't change, but this angle has to make sure that it's still a triangle to accommodate. So there's what the whole point here is there's a connection between the length of sides and the angles in a triangle. So what trigonometry does is it calculates that. If I know two of the side lengths, I can find the angle that makes it that way under some sort of particular circumstances. But for us, it'll always work. Okay. So now, if I know that this side length is twice that side length, I can figure out what the angles involved are. That's the idea. Or if it's 10 times that side length, I can figure out what the angle is. That's what trigonometry does. And if you think about triangles, if you visualize it, it makes sense. Once you have two side lengths, the angle has to be a certain way. Has to, because every triangle, similar triangles tells us every triangle is like that. So to start us off, let's get into this. Trigonometry, there's three ratios, basically three formulas. Sometimes I'll call them formulas. They're also they are ratios, so I'll often call them ratios, but they're formulas, same thing. Okay, there's three ratios we use to solve for a missing side length or angle. We are looking at right triangles only. What is a right triangle? Yeah, it has one 90-degree angle in it. It doesn't have two 90-degree angles in it. Can't have two. A triangle can only have one at most, right? So all the triangles we're going to look at this whole week have 90-degree angles. And in fact, in this whole course, we'll only look at 90-degree angles. In grade 11, you look at how to do trig with other kinds of triangles, okay? So here's the three ratios. It goes like this. The first one is SIN, which is short for sine. You don't need to know how to spell that, but that's how we say it. Everybody wants to say sin, but we don't say that as a habit because it's actually sine of this weird symbol. I'll talk about that in a second. Is opposite over hypotenuse. And I'll talk about what those words mean in a moment. We'll talk about them in a moment, but they'll mean more tomorrow when we get into this a little bit further. Okay? The second one is COS, and that stands for cosine. You can call it cos, that's fine. Again, of this weird symbol, equals adjacent over hypotenuse. Now this is what you want to write down 100%. You got to have this written down because this is the most important thing to remember about all of this is what these ratios are. Okay, so you want to have them written down in your book so you can look back at them after. And then the last, so this is cosine. Again, you don't have to know how to spell it or anything, but COS you need to know. And then the last one is TAN, tan, or tangent, is opposite over adjacent. But yes, adjacent. So that's tangent. This symbol that I'm using is called theta. And we use it for angles in mathematics. Sometimes we use X as well, but you'll notice we almost always use theta, so just get used to it. It's a Greek letter, and it seems weird to use that at first, but you'll get very used to it very quickly because you'll see it a lot. And I mean, if you think about it, when I use X or A or B or M or any other letter in mathematics as a variable, it's just a symbol. The letter itself means nothing. We use X a lot, but you could use any other letter. In fact, you could use any symbol. You could use a picture of a flower or a circle, like anything you want, right? Or a square, just as a variable. It just represents something. So we use Greek letters a lot as mathematics starts to get more complicated. What do you mean? Sine, cosine, and tangent, what's the difference between them? I'm sorry, I don't understand your question. No, go. I want you to ask it.
No, because it's a symbol of are you supposed to put the letters beside it?
I see, yes. Sine theta equals, that's the whole thing. I see what you're saying, yeah. It will make, this is all, there's a lot, because this is so new, there's a whole bunch of things that you need to be introduced before it starts to make sense. So don't worry too much about it now. It will make sense, especially tomorrow when we really get into this. Okay? Today's stuff is pretty easy. It's just we're practicing something so that we have this skill ready to start tomorrow. So these are the ratios that relate the side lengths to in a right triangle only, okay? Just like Pythagorean theorem only deals with right triangles. So it relates the side lengths to the angles in right triangles, okay? Make sense? There's a special word, I'm going to talk about it now, and then you don't really need it today, but we'll talk about it now and start getting used to it, and then tomorrow you will need it. It's a special word that we use just to memorize these three ratios or these three formulas, and it goes like this. So you probably want to write that down and say it. Start saying it to yourself in your head. You say it like this: Sohcahtoa. It's like famous in math class. You see posts about Sohcahtoa online, like jokes about it and that kind of thing. What's the one thing you remember from high school? Sohcahtoa. And there's other like little abbreviations or stories that people use to try to remember it. But Sohcahtoa is pretty easy to remember. And again, we don't exactly need it today, but if you just take a look, SOH stands for sine is opposite over hypotenuse. So you need to know the word. You need to know how to spell it, Sohcahtoa, and then it gives you those three formulas. So cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. There's a lot, if you think about this and you wonder about things, you're going to come up with a lot of questions like, what is sine? What is cosine? What is tangent? Like, what does that mean? I understand what opposite means, what adjacent means, what hypotenuse means, but I don't know what sine is. Yeah, fair enough. And it's very tricky to understand exactly what it is. But in a sense, it's an operation. It's a button on your calculator. And when you click it, it calculates the angle ratio. Okay, so don't worry too much about exactly what it is. We got to learn how to use it. Okay, there's two main parts to solving these questions. The first part is setting up the equation, and we're going to start doing that tomorrow. Today, we're only looking at solving the equations. However, we're going to practice sort of setting one up first to give it a bit of context. Okay, so we're going to take a look at one triangle today, but that's pretty much it. After that, we're working with triangles tomorrow. Okay, so here's the kind of question that's a famous right triangle Sohcahtoa trigonometry question. You don't have to write this down. You can if you want, but if you want to just watch, that's fine. Solve for the indicated side. So that means solve for x, right? That's what it's asking us to do. It's asking us to solve to find the length of that side. That's what it's asking us to do. This symbol tells me what? It's a right angle. Good. So this is a right angle triangle, and that's where the right angle is. And so does anybody know what the hypotenuse of this triangle is? Remember this from grade 9, Chrissy? 15. How do you know that? Longest side, good. That's what you're going to say. What else? Does anybody have another way of thinking about it? Yeah, it's across from the hypotenuse. So if I go across, from the right angle. If I go across from the right angle, I find the hypotenuse. Okay, whoops. Do that again. And we shorten it to HYP. Don't write H. You're not going to get away with that, but you don't have to write the whole word hypotenuse. We shorten all of these to 3 letters, so HYP. Yep. The hypotenuse is always across from the right angle, exactly, yes. So then, again, we're going to go over this tomorrow, so you don't need to know how to do this right now, but the first step is labeling the sides. The hypotenuse, we've started to label it. What does the word opposite mean? We know what opposite means, right? So if I go opposite from this angle, that's going to be my opposite side. So OPP stands for opposite. What does the word adjacent mean? Adjacent is one of those words that people know what it means. You don't use it that much, but if somebody said it, you'd understand what they're saying, but it's hard to explain what it means. Does anybody want to try? Explain what adjacent means? Sam, what do you think? See, it's hard to explain, right? But you know what it means. You're showing like connected, right? Touching. Yeah, very good. Near, beside. Chrissy, what were you going to say? beside, below, somehow really close to, touching, connected to, next to, something like that. So again, next to this angle, because we're always talking about an angle, next to this angle, touching the angle, is ADJ stands for adjacent. So when we look back at these formulas, these ratios, what do those words mean? Opposite, hypotenuse, adjacent. They mean side lengths in a triangle. That's just what they're talking about, okay? So in that fraction or that ratio are the side lengths of the triangle we're talking about, okay? And it might be opposite hypotenuse, it might be adjacent opposite. Like, we don't know. Every question's a bit different, but we're talking about side lengths. So now that I have this set up, I take a look at, I've got x with opposite. I've got 15 with hypotenuse. I look back to Sohcahtoa, and I think which one of those has opposite and hypotenuse in it, and it's sine. So I write sine theta is opposite over hypotenuse. Oh, geez. Silly. Over hypotenuse. Theta is an angle. Remember I said that? So it's sine of the angle that we were talking about, which is 68, equals opposite, which is x, over hypotenuse, which is 15 centimeters. And that's how I would set it up. And then I solve it. I know this seems strange. Don't worry. We're doing this tomorrow. We're not actually doing this today, but it's not hard. But I'm not going to talk any more about it because we don't need it for what we're doing today. It gives you a bit of context about how we're relating two side lengths to an angle. That's what this is all about. That's what opposite, adjacent, hypotenuse means. But we'll talk more about that specifically tomorrow. Adam?
Since you have adjacent down there too, couldn't you do the one?
Cosine or something? You could use cosine, but that wouldn't help you find x. But yes, absolutely, you're right, you could. Okay. Again, you don't have to write this down. So when we set up an equation, it always looks like this. Sine theta equals x over y, opposite over hypotenuse, or whatever those work out to be. Numbers or variables. There's three positions in this ratio for a variable. Angle is a variable. You might know it or you might not. The side length on top is a variable. You might know it, you might not. The side length on bottom is a variable. You might know it, you might not. As long as you have two of them, you can find the third. So when we look at our examples today, it's going to be solving for each of those. If I have theta and y, how do I find x? If I have x and y, how do I find theta? If I have theta and x, how do I find y? That's what we're doing today. Okay, so there's three cases. This is what you want to know. You want to think about this while you're working today. There's three cases. When we're solving for x, that's the variable on top. When we're solving for y, that's the variable on bottom. Or when we're solving for the angle. And each one of them has slightly different steps. This is what we're working on today. And this is what we're practicing. Any questions about that so far? We haven't really done much yet, but. So there's a quick explanation. This will be on, you probably haven't written this down. This will be in the classroom. That's okay. Don't try to write it down because I'm going to move past it in a minute. But this explains exactly how you solve each of them. So if you forget or if this is helpful, I can put it back up. You can write it down after, or you can look at it in the classroom and it'll be there, a description of exactly how we do it. So let's take a look at all three types. Here's one of each. So this is what you want to write down. And while you're writing down, notice that one of them has the variable on top, one of them has the variable on the bottom, and one of them has both side lengths are given, and it's theta, the angle, that we don't know. So this is one of each type of equation that we're going to see in trigonometry. Even if you just get the first one written down right now, then we're going to start with question A. So this is the kind where there's a variable on top. Folks, these are like equations. Just simple, sort of one-step equations. Watch what I mean by that. If I come off to the side here, this is like if I had 5 equals x over 3. How would I solve that? Multiply both sides by 3 to isolate x. Does that make sense? So that's exactly what we're going to do here. We're going to multiply both sides by 34. And the 34s divide to 1. So I end up with 34 sine 48 equals A. And pull out your calculator because you cannot do this in your head. It's not possible. Okay? You have to do it on a calculator. So you have to have a calculator with sine, cosine, tangent, but I think all of you do. Phones do have it, although I think the iPhone one does. I think they all do, but honestly, they're not the best for this stuff. So you really want to get used to using your own calculator. Everyone's a little bit different, but I'll go through the different types. And part of today is learning how to use your calculator. So if you're not getting the right answers while you're working, you want to put up your hand and say, I can't figure out how to do it on my calculator. Okay, and I can help you with that in a minute as well. So there's another thing that you need to know is every calculator has, or almost every calculator, you'll see a little like D, the letter D. You might have always wondered what in the world is that. Do you see that on your calculator? Again, on a phone you might not. It's on the screen at the top. Well, you've got to turn it on first. DEG. Sometimes it says DEG or it says D. That's good. If it says anything else, your answers will all be wrong. Has to be, that stands for degree because our angles are measured in degrees, so it has to be in degree mode. And on my calculator, so just listen for a minute. If you have a 2-line calculator, you're going to do this. 34, find the sign button, 48, and hit equals. And what do I get? Nice. So A equals, I'm rounding, so approximately 25.3. I'm going to round it to. We don't have units. We will for the most part, but today there's no units. And usually side lengths we round to 1 decimal place. So 25.3. If you have a 1-line calculator, you're going to do this. So listen carefully. I'll walk you through it again after, but you're going to do this. 48. Then hit sign. Then hit times 34 equals. And you should get the same number, 25.266924, so on. Let's try another one. So remember, these are the 3 types. That was x on top. That's what I call it, x on top, variable on top. Even though it was an A, I always just call it x on top. So this is like x on the bottom. Okay, my variable, my unknown is on the bottom. So again, what I want to do is I need to get it to the top. We're going to cut this down to 1 step. And if you practice this and you know the shortcut, it's really easy. But I'm going to show you why the shortcut works first. I'm going to multiply both sides by b because I don't want it on the bottom. And in other cases, we flipped both sides, but it's not really going to work here because we only have 1 fraction. So I'm going to multiply both sides by b, and that's going to cancel out there. And I'm going to end up with b times cosine of 71 equals 16.2. And then I'm going to divide both sides by cos of 71. This is a little bit weird, but cos 71 is a number altogether. Like that seems weird, but it is. It's one thing. You can't move the 71 away without the cos. You can't divide both sides by 71. That is not a thing. So we have to divide both sides by the whole thing. Again, you'll get used to this, don't worry. It does seem weird at first, but this is, again, like I said, honestly, a lot of people find trigonometry their favorite type of math. It's easy, straightforward, repetitive. You get it. Okay, so again, this divides out, and I'm left with b equals 16.2 over cos 71. But it does take some practice to get it and to get it right every time. So notice in the first one, x was on top, we ended up multiplying. In the second one, x is on bottom, we end up dividing, and that's all explained right here. So the way I look at it is cos 71 and b traded places. When you have your variable on the bottom, they trade places, and you end up dividing. The people who don't practice just try to multiply every time and get half the questions wrong. Okay, so how do we do this one? I go 16.2 divided by cos 71. Make sure my calculator's in degree mode, hit equals, and I should get. Nice. You want to make sure you can get these on your calculator. You would not be able to leave this to the test and figure it out during the test how to use your calculator. That will not work. I won't teach you how to use your calculator in the middle of the test. I'll help you if something weird is going on, but I can't teach you then, right? So we can practice now and get it now. Any questions? Yeah. So either, let me see your calculator. Okay, so you have to do 16.2 divided by 71 cos equals.
Okay, the last time I did 16.2 divided by
Cos, yeah. So like, perfect example. You got to learn to use your calculator. If you practice right now with a phone and then try to use a calculator on the test, you're going to be in some trouble. You know what I mean? Any questions? Other questions? Okay, one more. So we did x on top, we did x on the bottom. Now this is looking for an angle. We're looking for theta. This is a one-step answer. I'm going to show you an extra step that you should write into your notes to remind you how to do it. But there's a little trick. And again, this is what you're learning today, how to solve each of these three types. You have a button on your calculator that either says shift or second F, second function. So we're going to use that. And when I do second function cos, or shift cos, I get this. Cos -1. You see that on your calculator? So in this case, theta equals second function of 12 divided by 30. That's what I type into my calculator. I'll help you in a minute. So we hit shift or second function and then cos to solve for an angle. And again, that's explained right here. Look, when we solve for an angle, must use the shift second function button on a calculator. It seems weird. You practice a few times, it's easy. So on my calculator, I go shift cos bracket. You got to do a bracket. 12 divided by 30. I hit equals. And I get rounded, we round these to whole numbers, 66 degrees. On your calculator, if yours is not two-line, you might do it like this. So listen carefully. 12 divided by 30 equals. And then shift cos. So Jake, for you, you're gonna go shift cos bracket. Yeah, so you don't need an extra one. Again, it's all about learning your calculator. That's right. So Adam, 12 divided by 30 equals, and shift cos. Okay, I want you to try these three.
What was the answer?
66 degrees. 66.4218215. So I'm going to let you try each type. I'll come around and help you with your calculator. The work is posted to the classroom. I'll put it up when we're done this. We will take these up and I'll show you the right answer. And if you want to look at it again after, you can find it in the classroom.